Okay, so very first thing we got here, it says to write a linear equation in given the slope of the line and a point that passes through it, use the point slope formula. So for this one, we're going to basically need a couple of different things in that part of it to make it start going there. So if we go through point slope formula, point slope formula would be y minus y1 equals m times x minus x1. Okay, and I know that when we start graphing things, we usually don't normally graph it from that position. So this is basically your starting point, if you want to think about it this way. Because a lot of times when we're working through different parts of it, sometimes people don't know what to do. So a lot of times if you get stuck, this is where you start. That you can always take this and go to any other equation that you have really easily. So this is always kind of your go-to if you get stuck on some different things. Okay, so very first thing is they have you just plug in some numbers with this one. And again, the big thing is you just need to make sure that you're okay labeling the points and plugging stuff in. So that's the first and only point that we have. So that's going to be x1 and y1. Okay, so when you plug that in, that's going to be y minus 7 equals -4 times x minus -1. Okay, with the minus 7, there's not a double negative on that one, so it's just y minus 7 equals -4. On this part, you do have a minus negative, so then you can make that just x plus 1. Okay, and as long as they ask you to leave it in point slope formula, that's all you have to do. Is that if you have some double negatives here, you have that part of it. And for those of you that are thinking about, well, what if we want to graph these? Well, that's where we would go back and again, not graphing these today, so we may do a review for that for another day. But that's where you would go back and do some distributive property with your -4, and then you would add 7 both sides. And that way you would have it back into an easy way that you need to graph it with your y equals mx plus b. But for now, again, we're just kind of making sure that we're okay plugging some numbers in and just being okay with having everything kind of set up in our situation that's here. Okay, so for number 2, we've got this is our x1 and our y1. So it's y minus -5 equals 2/3 times x minus -6. Okay, and again, where you have the minus negative, just need to make that into a plus. Leave the 2/3 like it is. Okay, and again, as long as they ask you to leave it in point slope formula, that's all you have to do in that case. You're pretty much just plugging in the numbers and doing a little bit of simplifying, not very much at all there. Okay, so next thing, it says to write a linear equation given 2 points, x1, y1, and x2 and y2, use the slope formula, and again, for your slope formula. And I think we may have mentioned this a little while back, that sometimes people will put y2 minus y1 over x2 minus x1. Okay, but you also can use, and this is the one I usually wind up using more often than not, y1 minus y2 over x1 minus x2. I kind of like putting the first number first and the second number second. You still get the same answer. It just, it's just going to change up the order. So if this was -4 over 5, this winds up being 4 over -5, but the answer is still going to be negative as you go through that one. And then once you've got your slope, then you can plug it back into the point slope formula. Oops, sorry. So y minus y1 and then m times x minus x1. So anytime they give you 2 points, you want to find the slope first. And then once you've got your slope, then you can go back and use your points that you need there. Okay, so there's 2 points. So first one's x1, y1. Second one is x2 and y2. Okay, so very first thing, we'll do this over on the side over here, is we're going to figure out what the slope is. And again, I'm going to use this one where we do y1 minus y2 and x1 minus x2. That's going to be 1 minus 7 over -6 minus -3. And anytime I'm plugging in negative, especially those second numbers, I'm going to put it in parentheses because that's 1 minus 7, which is -6. That's -6 plus 3. So that's -6 over -3, which is just 2 for your m value. Okay. And again, the only difference is if you had used the blue formula here with y2 minus y1, x2 minus x1, instead of being -6 over -3, it would have been +6 over +3. Still get you 2. So all it's going to do is just change up the signs for the numbers that you have here. Okay, so now that you've got this as your m, now we're going to use this for x1 and y1, and we're going to plug it back into this formula. So that becomes y minus 1 equals 2 times x minus -6. Or y minus 1 equals 2 times x plus 6. All right, now I'm sure somebody's thinking this. Well, and somebody may be asking, what if I didn't label that as x1 and y1, and what if I switch these up? What if I labeled this as x1 and y1, and this was x2 and y2? Which you could do, because it doesn't have to be that this one's always x1 and y1. You can label those ever how you want to. There's actually 2 correct answers for this one, because you can also take that slope of 2, and then you could use this for x1 and y1 if you wanted to. So you also could have, here's our or statement here, because it could also be that it's going to be y minus 7 equals 2 times x minus -3. So it could be that. So this would be one of those problems where either, if it's a test question or if this is something on ACT you're going through, there's actually 2 correct answers you could have here. You could have that answer or you could have that answer. And again, if you take this answer and stretch it out and put it in y equals mx plus b form, so if we we're going to graph this one, you would see that they wind up being the exact same answers. So if we do distribute property with a 2 and then add 1, we get 2x plus 13. And for this one, if we did distributed property with the 2 and added 7, you still get the exact same thing. So the good news is on that one is, if you're going back to y equals any of these point slope or slope intercept formulas, there's, depending on where we get here, this is only the halfway point. So there's actually, 2 correct answers that you can use here. All right, we'll do a couple more of these and we'll wrap this side up. Actually, let's do this. Let's do number 6, because number 6 is because most of these are pretty straightforward. 4 and 5, same thing, just repeats on this one. 6 is a little bit different because it's a trick question here. Okay, so there's our x1 and our y1, and our x2 and our y2. If we go ahead and find slope, and we'll put that over here so we've got plenty of room. Again, I'm going to go with the y1s first. That's going to be -3 minus. Okay, so we've got -3 minus -3 over -8 minus -2. So that's -3 plus 3. That's 0 on the top. We've got -8 plus 2, which is -6 on the bottom. Okay. 0 over -6. Yeah, slope is 0. You may go, what does that do with our equation? Well, let's plug it in and see what happens. So if you plug this thing in, so now we've got y minus, and again, y1 and y2 doesn't matter. It's still going to be -3 in this case, equals m times x minus -8. So it's y plus 3 equals, what happens when you do 0 times anything? 0, right? And it doesn't matter that this is, if we make it x plus 8, it's still 0 times x and 0 times 8. That's still just a big fat 0. So you've got y plus 3 is equal to 0. Okay, now, and if you do that, if you plug the numbers in and you've got 0, and let's say your x's are gone or your y's are gone, whatever, you pretty much just solve for whatever variable is left. So for this one, we wind up subtracting 3 from both sides. So that equation would actually be y equals -3. Yeah, so that's one of those kind of weird trick questions, situations where when you plug it in, you've got zeros and everything goes away, and you're like, okay, what do we do? Well, you just basically solve for whatever variable you have left over, and that'll kind of get you going the right way. Okay. And again, if that's a 0 slope line, basically that winds up being a horizontal line, so it's a line that looks something like that when it gets off of it. Okay, and the last two at the bottom. Got to throw in a couple word questions here. Okay, it says the cab ride cost. We're doing slope intercept form on this one. For slope intercept form. That's y equals mx plus b. All right, and for these, you have to kind of have some way of to me, always kind of putting these things together. When they're talking about y equals mx plus b, the b is where you begin, and the m for slope is the next thing. It's how you move to the next point. So when I was going through and figuring some things out on this one, I always like for stuff to kind of make sense. One of the variables names are what they are, and like, why do they put m and b? Well, b is where you begin, and m is how you move to the next point. That's the slope. That's the the 2/5 or the slope or whatever we're going to do for that thing. And eventually, it may not be in your lifetime, but I'm hoping it will be. If this is where you begin, shouldn't that be the very first thing that you put? I think eventually it will probably have this, because to me that makes more sense. If this is the beginning, it should be the first number, right? I actually heard some other math teachers talking about this a while back that they actually agree with that, and they were just talking in a rant. I didn't bring it up, but we're just in a conversation. I thought, well, to me that makes more sense. We're not there yet because this is the way we've always done it, and sometimes it takes a while of trying to get from here to here. So, we'll see. Okay, so we're going with y equals mx plus b. So it says write an equation to talk about the cab fare, what we got. So cab ride costs $4 plus $1.75 per mile driven for this thing. Okay, so if you sit down in the cab and you go 1 foot, it's going to cost you $4, right? So in that case, your B value would be 4 because you're going to begin at $4. That you sit down in the cab and they start the timer, it's $4 no matter what you do, and then it's another $1.75 per mile. So in that case, your slope is 1.75 because that's what you begin with, and then as you start to move, that's how much you're going to get paid per mile. Okay. It says define your variables. So x in this case, let's say, so y is going to be our cost. And x should be the number of miles that we're going to go. So for every mile we go, that's what we're going to have. So if we write this in y equals mx plus b form, that should just be y equals 1.75x plus 4. Okay, and then the B part says, okay, if Clay is taking this ride he's going with, and he's 17 miles away, he's got $30. Is he going to make it? Okay, so now we know our x is 17. We're just going to take that 17 and plug it back into this equation and see what we get here. Okay, so if we do 1.75 times 17, that is, and we'll save you a little bit of time on this one, 2975. So if he's going to go 17 miles, it's going to cost $33.75. He's only got $30. So is he going to make it? Nope. Going to start walking that last little bit, right? Going to get about 14 miles in. Cabby's going to go, all right, that's it. You're out. You go. Okay, so again, that's some review stuff, kind of going back and picking up on a few things. It's good to go back and pick up slope for this part just because, again, sometimes just working with some of the numbers, just introducing zero, sometimes some trick situations, some special situations, kind of puts us in a different situation where we're going. Okay, on the backside, here's something that we're going to talk about that's going to get us through a lot of different things that we're going through. Interval notation. And it's really, really similar to just your graphs. If we're graphing, x less thans and x greater thans and that kind of stuff. So if we go back to this one down here, we'll come back to actually this one in a minute. You've got x is greater than 2 for these. So if you do or don't remember, we'll kind of put this at the top up here. If you want to graph inequalities, let's say we're doing x is less than 4. So we're going to go back to what you've always done in the past, and this will kind of walk us where we're going for the future here. If you had to graph something like this, if these were numbers, if this was 3, 4, and 5 here, this is where you would put an open circle at 4. And if nobody ever showed you this, then I'm going to show it to you now. As long as you put the variable first when you're graphing inequalities, this arrow always tells you which way to shade. You've got to shade in this direction. So that this arrow should always match the arrow of the shape that you're going here. If nobody ever showed you that, then shame on them. Somebody should have shown you that. Okay, if you're graphing x greater than or equal to negative 10. If there's our negative 10, that would be negative 9, that would be negative 11. If you put the bar underneath it to make it the less than or equal to, the big difference is in that case, when you put your circle here at negative 10, it's a solid circle. Right? And again, the arrow is pointed this way. So same thing over here. When you graph this, the arrow has got to point that way. And that, again, that only works as long as you put the variable first. If you put the variable first, the arrow always goes the same way when you go through these. Okay, so that's what we were doing before when you were graphing inequalities. Here's the big thing with interval notation. Okay, so what it's going to do, and you may be asking, why do we always have to change stuff? Well, when you're getting into pre-cal and some other things that they do, the notation they like for it to change because it gets a little confusing sometimes with what's going on. So we just have to kind of see where some of this stuff is going. So the biggest thing is that before, if we're graphing inequalities, we have our less thans and our greater thans here, that this was an open circle. But in interval notation, now it's going to be parentheses. Okay. Now, graph-wise, it's still going to look the same thing because you're still going to, it's probably going to be like a 3-part process. They're going to give you an inequality. They're going to ask you to graph it. And then we're going to use the graph to then talk about what it's going to be in interval notation. So whenever we see the open circles that we had here on a graph, that's when we're now going to use parentheses. If it's less than, equal to, or greater than, equal to, it was a solid circle. And now it's going to be a square bracket. Okay, and we're talking about a square bracket. That's where it's going to be just like that. It's going to be almost like a sideways staple, if you want to think about it that way. Okay. Now, and one thing that we're going to do with these that we didn't really talk about back here is that the other part we're going to have with this part of it, I'm just going to put this over here. If you have negative infinity or infinity, you're going to always use parentheses. Okay, and then one other small thing you have for this one, when you're going to use interval notation for this part of it, because basically you're going to have two numbers. If you notice what's on here for this one, the very first example, it says we're going to go from -3 to 5. -3 is less than or equal to x, which is less than 5. So on the graph, that's where we'd have a solid circle at -3. We'd have an open circle at 5 because it's just the x less than part on this one. So in interval notation, again, solid circle becomes a square bracket, open circle becomes a parentheses. And the one thing you always want to make sure when you do interval notation is the first number, your smallest number, is always first. Because sometimes we would do this one, and again, just this is where doing it in years past, people would put the answer and they'd put like 5 and -3. I'm like, well, no, you always have to put your smallest number first. So the number farthest to the left always needs to be the first number that's on the left. So the order of the numbers needs to match up with where they would be on a number line. Okay, so we've got the first couple ones here where they do for you. Again, this is more of like kind of like we're doing up here. This is x greater than 2. So if you think about it, all the numbers that are greater than 2 means you start at anything bigger than 2, 3, 4, 5, 6, 7, 8, and that goes to infinity as far as numbers go. So that's basically going from 2 out to infinity. So when you graph this one, here's kind of what you want to think about. If that's the graph we have going this way, you tell me the lowest number on this that we're going to graph, which is 2. You tell me the biggest number. So this thing goes to infinity. So that's why we're using 2 to infinity. Okay, and then the rest of it is just, they kind of give you those first two to go through. The rest of these we're going to fill in the blanks, let you see what's going on. There's a couple of them that I wouldn't say it's a trick question, but just some of them that, when you look at them, it makes you go, just a little bit. Okay, so before we do interval notation, let's go over here and graph this one. Okay, and you don't have to graph, 16 different points like they did. I'm fine with these of just giving me the number in the middle and then give me 1 point on either side. So this would be 2, 3, 4. All right, so we're going to practice our graphing. So at 3, we got a circle. It's got the bar underneath it, so we'll make it solid. Arrow is pointed to the left. So that means we got to go this way, which means we're going to shade in everything here. Okay, now, and here's all the interval notation does, is that we've solved this inequality, we've gotten down to this answer, we've graphed it, which we can do because you've been doing graphs forever. Here's where the new part comes in for this one. If it's x less than or equal to 3, 3 is our highest number, so that's the number farthest to the right, so we'll put it there. It's got a solid circle, so that means it's going to be a square bracket. And then basically you tell me, all right, what's the number farthest to the left in this thing? Well, it goes forever, correct? So if we do that one, we're going to say that's negative infinity. So we're going to go from negative infinity, the lowest number, up to 3, which is our biggest number. Okay, and that's all the interval notation is going to do is just take, what we have here. Instead of having to draw a graph, we're just going to give it to you with a couple of points. Here's our lowest number. Here's our highest number. Okay, so for this one, if we graph it, almost exact same graph in that case because there's 3, 4, 5. It says we're going to start at negative infinity. We're going to go up to 4. So 4 is our highest number. In that case, it's got the parentheses on it, so it's an open circle. And we get to go all the way to negative infinity. So our graph looks something like that. Okay, and if that's our graph, put that in terms of inequality. That's going to be x. And again, notice the arrow is going this way. So this inequality has to match up to be the same thing. So that's x less than, and then just give me the number 4. Okay, so interval notation is just one more tool you can add in when we're talking about inequalities or graphs. And probably in a lot of cases is when we start solving things, they're going to have you do less graphs and more of, okay, here's this answer, and then tell me what the answer is going to be in interval notation. So they're going to kind of transition you away from graphs is basically what we're kind of looking at for this thing. Okay, so number 3, and this is one where it's actually easier in interval notation. Lowest number on the left is 2, highest number is 6. So if you put your numbers in there, there's 2 and 6. 2 has a solid circle, so that's a square bracket. 6 has a solid circle. That's a square bracket. Okay, if they ask you to write an inequality, basically here's what you're going to do. You're going to put the 2 over here. You're going to put the 6 over here. And you need any number in the middle, so we're going to put x in between. And to make it go in between, we're always going to have it so that it basically just does less thans. And basically what's going to happen with this one is most people are usually okay with this part because they're like, okay, I understand x is less than 6 because that's the solid circle here headed this way. And they're like, well, what's up with the 2 less than equal to x? Why don't we put the x first, like we've always done? Well, in that particular case, if we've got x is greater than 2, that's everything that's a solid circle at 2 going this way. And then if you've got x is less than equal to 6, that's everything at 6 going that way. So this is one of those cases where they just wind up flipping this one around and say, all right, well, 2, if we flip this thing around and put the 2 first, now we've got 2 is less than equal to x, and x is less than equal to 6. Since it's together here, we can just take that out and just rewrite it like that. Okay. So that's the reason they kind of throw that one in this way is that if everything is kind of sandwiched in between 2 numbers, you just have it so x is sandwiched in between those 2 numbers. Okay, number 4, we've got 5 to infinity. Sorry about that. 4, 5, 6. Lowest number is 5. It's a square bracket, so it's a solid circle. We're going out to infinity, which is that way. Okay, so there's our graph. Okay, again, arrow is pointed this way, so arrow's got to point this way. And then we started at 5, so we're going to put the 5 there. Okay, now the only thing we need to add for this one again, solid circle, so it does need the bar underneath it. Okay, and here's kind of hopefully the thing that you kind of notice. If it's just one arrow going one way, you can hopefully start to see that these two things kind of tie in. So this one's going to the left, so that arrow's got to be less than. So anytime you're pointing to the left, that's going to be less than. Anytime you're pointing out to the right side, it should be a greater than type thing. This one's a solid circle at 1, so I need the solid part there. And then interval notation, it's negative infinity up to positive 1, and square bracket there. Okay, and 6 is the first time they throw a little bit of a curve at you here. Because 6, they throw an OR at you, and you're like, okay, what do we do with an OR in this case? Well, let's get the graph first. 1, 2, 3, 4. Okay, so we got x is less than 1 or x is less than 5, so that part we can graph. So we've got an open circle at 1 headed this way. We've got a solid circle at 5, and it's headed that way. Okay. So there's our two graphs we've got. The OR statement doesn't really do anything with it. We still just graph those two pieces. Now, if you put this in interval notation, if you looked at just that half of it, it would be from negative infinity up to 1. It's an open circle there, so we'll put a parentheses around it there. And then basically, if there's two parts where you got like a part A and a part B, where it's either this thing or this thing, in the middle, you're just going to put a U that says, all right, it's going to be this part of the graph combined with this part of the graph. So now that part of the graph starts at 5 and goes out to infinity. So if it's an OR statement, it's just like a two-part graph on that one. You can almost think about the U as being like a comma. You know, we're doing this part of the graph, comma, then we're also doing this part of the graph as we go through there. Okay, 7. We're stuck in between -5 and -1. So this one's actually not bad. We'll do -5, -1. Both of them are open parentheses, so are open circles, so they'll both be open parentheses. And again, we're keeping everything between those two numbers, so we're going from -5 to -1. X is in the middle. They're both open circles, so they'll both be less than. Okay. 8 is a trick question. It does pop up every now and again, though, so it's kind of good to look at this one. Okay, x is any real number, which means anything on the graph is good to go. So if it's any real number and you graph this one, basically here's what you're going to do. You're just going to put a graph and you're going to shade the whole graph. You're like, well, what do we do for interval notation then? Well, tell me the lowest number. That's negative infinity. Highest number is positive infinity. So in that case, we're just going to go negative infinity to infinity. Okay, and the last couple few here at the bottom. For this part, we're going from, and again, it's a two-part because we've got this part of the graph and then this part of the graph. So this part of the graph, we're going from negative infinity up to -1. The 1 has a solid circle, so it's a square bracket. And then we're going to go from 2 to infinity. So we're going to start at 2, open circle, so it's parentheses, and then chase that out to infinity. Okay, and then answer-wise for this one, it will look a lot like this one. It's the OR part of it. So we're going to have x is less than or equal to -1 if we look at just that part of the graph. And we're going to put the OR in. And then we'll look at the second part of the graph. That's going to be x greater than 2. Okay, so for 10, we're going from 1 to 4. They're parentheses in that case. So open circle at 1, open circle at 4, and then everything in between. So again, if we're staying between 1 and 4, x is going to be between 1 and 4. Open circle is all the way around because the open circles will then make it just be less than. Okay, and the last two, if you want to fill those in real quick, just see what you think, and then we'll wait just a second to show you what those answers are, and then that'll wrap us up for today. Okay, so we're real quick on this one. X greater than 7. 6, 7, 8. Should be open circle at 7, headed that way. So interval notation wise, we've got an open circle at 7, headed out to infinity. Okay, so for 12, going -2 to 2, that's a solid circle because of the square brackets. Solid circle there and everything in between. So again, in that case, x is in the middle. We're staying between 2 and -2. They both are square brackets, so that make them both less than or equal to. All right, and for the people who are wondering why we're using absolute value always with the parentheses, because you may be going back up here to this one where, like with number 5 or number 4, we've got greater than or equal to. We're using a square bracket on this number and there, and you may be wondering, well, why are we not using a square bracket with the infinities on that part? If you remember, with the open circles up here, when we had those, the difference is that if you had, x was greater than 2 or x was greater than or equal to 2. If x was greater than 2, you could not use 2. You always had to have 2, like 2.00000001. If x was greater than or equal to 2, you could start at 2, and then you could go from 2 to 2.01 or 2.0001 or whatever. So basically, if it's got this underneath it, then that means you get to include that number. So if you're using infinity, how can you include infinity if it goes forever? So if somebody gives me a number, somebody give me a huge number, 300. Can make it bigger, right? 301. Well, if I tell you, somebody says 300 million, all right, they give you 300 million, 1, and you're like, well, I'll go bigger. I'll give you 300 million, 2, and I go 3, and so then it's just a battle the whole time, right? So if when you've got the brackets like this, it means you get to stop at that number. You can't stop at infinity because any number you give me, you can always add 1 to it. So it just goes and goes and goes and goes forever for that part. So that's why anytime you're using infinity, you're always going to use parentheses because you don't actually get to stop at that number because infinity goes forever. So, that's why regardless of what this number is, infinity or negative infinity will always use the parentheses because, again, you never can reach that number because it will just go and go and go forever as we go through that.